Well, in Module 9, we're talking about momentum. Now, momentum is one of those words in physics that actually means pretty close to the same meaning that we use for it in everyday life. We talk about movements gaining momentum, or we'll talk about trucks or other large objects having momentum, or we'll talk about an idea gaining momentum with people. And generally what that means is that once it gets started moving, it tends to keep moving. And so in physics, momentum is defined as the mass of an object times its velocity. And we instinctively know that the greater the momentum an object has, the more likely it is to injure you if it hits you. So for example, if an object is coming towards you, we just instinctively know that the bigger that object is, the more mass it has, the more it's likely to hurt when it hits us. We also know that if you've got two objects of the same mass coming at you, but one is moving much faster than the other, we know that the object is moving faster is much more likely to cause an injury. And so these topics that we are aware of from everyday life also apply in the field of physics as well. So when I talk about momentum, I define momentum with the letter P to stand for momentum, and then that's mass times velocity. Now, we know from earlier that velocity is a vector quantity, and so it has a certain direction specified with it. We know that mass is a scalar quantity, so since velocity has a direction with it, that means momentum must also have a direction with it. And what's true is that the momentum of an object, its particular vector, is going to always be pointing in the same direction that the velocity vector is pointing. And if you think about it, that makes sense. If you have a truck moving this direction across your screen, then the momentum is going to be going the exact same direction. It's not going to be going the other direction. There are no special units associated with momentum, but the SI units that we use for mass are the kilogram, and the SI units that we use for velocity are meters per second. And so the units for momentum are just kilogram meter per second. It doesn't have any kind of a special name like a Newton or a joule or anything like that, like some of the other topics that, some of the other quantities that we've discussed. So if you look at example 9.1 in your book, it says a 345 kilogram car travels with a velocity of 19.1 meters per second southwest, and it asks what its momentum is. Well, this is just a straightforward use of the momentum equation. So we're being asked for the momentum, and the mass of the car is 345 kilograms, and the velocity of the car is 19.1 meters per second. So I plug that in. When I multiply those numbers out, I'll have three significant figures in my answer, and that will give me an answer of 6,590 kilogram meter per second. But since my velocity had a direction on it, since it said it was southwest, my momentum will also need to have a direction on it, and so the momentum will also be in a southwesterly direction. Okay, so if you've been given a direction for velocity, you need to make sure that you put that same direction on your momentum when you calculate that. So there's an introduction for momentum, and we will continue on that in the next video.